So I had to pause it and take care of something, and at this particular point I don't have things lined up very well, but we'll try our best here. Okay, so what we saw that this load could be replaced by equivalent load right in the center that was 100, this value, times the width of 10, which gives you 1,000. So then we put a load right there in the middle. What we determined was that the reaction loads became the same. However, the shear diagrams are not the same. So let's look as to why. Let's just pick a spot at about 5. Or how about, since 5 is a transition point, let's look at 4. Let's look at about the value of 4 here, and that'd be somewhere around here. And let's compare this. So what we'll do, quick free body diagram up on the top, get you, and I'll try to do the best I can. As a matter of fact, you know what I'll do? I'll make use of the picture itself. And I'm going to do something very interesting here. What we're going to do, there's what we're going to do. I want to do a snip. That's not really a, that's not what I want. I want to see that. And then I want to see snip. Let's do a new one. Oh, still going to be goofed. So here's what I've got to do. I'm going to come off full screen. Take a snip. And I'm going to go out here to about 4. Now what I'm going to do, put it right there. And I'm going to say that the distance here from here to here is 4. Oops. So if its distance from here to the end is 4, that means the total load and let me see if I can get back here. Alright, so if this is a distance of 4 and this is still 100 pounds per running foot, then this becomes 400 pounds. We have to remember that it is still like a free body diagram. The question is, if this is 400 pounds, then I have to have an upward force of 875 minus 400, or, oops, I'm sorry, downward force of 475, because I add this to that and I would get this. So the shear would be 475 there. Is that true? Well, it's hard to say. This is a straight line we see. Slope, rise over run. The rise is 875 and 125. So that'd be 900 or 1,000 divided by the run, which is 10, which would be that. So this means if I start at 875, and I subtract off 4, because that's how far I went over, times 100, well, just following that as a straight line, 475. So, turns out it matches. But let's look at this one. Free body diagram here is much easier to look at. I'm going to just not even take a picture of it. We move out here 4. I have 875 looking here. This has to be 875. So as I move out here until I get 5, it has to be 875 the whole way. Why? Because as I move this part of the cut, as I move to the right, nothing happens until I come under this load and move to the other side. Here's a typical example. Let's now say I move out here to 6. Have 1,000. Looks to me like I gotta put up 25 to get to 900, and I gotta put up a 125. And I stay at 125 all the way until I cross this 500 pound load. So even though the reactions are the same, the concept of what the shear is as we move to the right is not the same. So the shear diagrams are not the same, even though I start at the same shear force of 875, because the reactions are the same. The rest is not the same. Okay, let's move to the moment diagram. Let's take a look at this one first. Let's go ahead and take our value of 4. We essentially have a 875 here and an 875 here. However, if I just had that, so I put an object in space and put a force like this, it would start spinning. Even though some of the forces in the Y were the same, some of the moments can't be. So I have to put a moment out here. And what is that moment? In this particular case, since I've been talking about 4, it's going to be 4 times 875. Let's go look down. Find our moment diagram. Moment starts at 0. What does it end up at? 4. Then we're just going to look at this as a straight line, and we want to find the value I end up at. Rise over run of this curve. Rise of 375 over the run of 5, and for some reason I do not have octave up at this particular second. I'm waiting for it. There it is. Now I have 2 versions of it. I'm now going to have to wait. I don't know what's going on. Okay, looks like I got one finally. Ah, looks like I have none. I'm going to pause this, try to get this started. Okay. Rise over run. 4375 divided by 5. 4375 divided by 5 gives me a slope of 875. Means that this is 875. So if I move out here to 4, then that would be 4 times 875. But wait a minute. That's exactly what you got here. So in fact, this is something you will find out, is that this flat or constant gives you a linear, linear gives you a quadratic, and this is something you're going to learn from in mechanics and materials. So how do I find the moment on this left one? Let's just take this piece, draw it out. Looks like I had 875 here. I had this load here, but it's the equivalent of sitting right in the middle. And its value was 400. Gave us a shear of what? 475. However, what's the moment? Remember, this is 4. So the moment sitting over here is going to be 875 times 4 minus 400 times 2, or I think I just typed in 2700. Did I just type in the right equation? Yeah, 2700. So now you head along in here. Now this one I'm not going to work that diligently on. This is probably about 5. This is probably about 4, somewhere in here. And so this is probably close to the 2700. So in fact, all this information can be determined here. So I'll call this video to a close, bring it to a close, and kind of go from here.